So, yeah, so let's see, we're working on the runic language. Yeah, let's see, last time, what did we do? We did some LSP stuff. I fixed some stuff with the pipelines. Yeah, we did import completions. That was basically it, I think. Yeah, we did the import module named completions. And we fixed some bug with the pipelines there. So oh yeah, and then I asked, like the last thing I did was I asked the LS or the AI to like investigate an issue when restarting the LSP. Like when the LSP restarts, it leaks a bunch of memory and then it crashes when you restart it. So it got me to look at some of the things that use like resolve URI function, except we only have resolve URI path. So in parser, oh, I see this one, the parser. Okay, well, I thought that, okay, well, I was looking at this resolve URI path because this one actually returns like a duplicated thing, and so, and then we append it here to roots. So that is like properly handled, like the roots are added to like the workspace, and then the workspace will handle the initialization of that. But then we have things here like path here, and then we free it after. We put path in here, so we have to make sure that so I was thinking like, hey, why don't I just, for things that are that could be, you know, you send in a string somewhere, you don't know where it ends up and stuff. We could I was thinking like, okay, well, how about just implementing a reference counter? Hello, Penguin. How's it going? So the reference counter is, yeah, I've never done anything like this, but I basically have this reference counter type here. So you can put in a type that you want to create. Now this only works for a singular pointer, like item. I don't have lists yet, but I think we need to kind of copy this whole thing and make it work for lists as well, and have a separate type for that. Unless you can maybe put in an option here to make it into a list, but yeah, we'll see. But anyway, because of the way it needs to be created and then destroyed, like if you could have a list, like a dynamic list, I guess, and then as long as this knows how to like deinitialize it. I guess if you have something that is supposed to be able to be deinitialized, like this could just call deinitialize on the value itself, and that could also work. But anyway, it's basically like this. We have this original like reference counter object which stores the allocator used, and that we're gonna use to store it and destroy it. We have the pointer, which is optional because of when it's not valid, it's set to null, and then we can actually check instead of getting like a seg fault or something like that. And then we have the number of refs here. So at the start, you will call init. You will get this reference counter out. So let me actually show you in the tests here. So basically, let's do a simple one here. So you initialize the reference counter here, which in this case is a reference counter of a slice of like a constant string here. So we just put the string in there, and to get a reference out, you just say reference. And the point of this is to have a shared pointer, so you don't have to duplicate the string over and over. and you know, handle it over and over. But you do have to release it when you're done with it. So yeah, that's the thing. Like you still have to release the string when you're done with it. So yeah, you have to sort of handle all the strings, but it will be a shared pointer, so you don't have to duplicate it, and you're safe to release it. And when it's released, when there's no reference left, then the whole thing gets deinitialized as well. So yeah. So basically here, at this point, the reference counter is kind of in a initializing state, you could say. And when you create the first reference, what's happening is that we just increase the reference counter by 1, and we return a reference object which has the reference counter in it. And this is also a null optional here, because the reference, like once the reference has been released, we shouldn't be able to like call release again. So we have a guard against that here as well. So it's basically like a kind of like a safe way to share a pointer, I guess. And when the thing has all, like when everybody has released the reference, it will get it will get deinitialized. So when we release, we call release on the reference counter object itself. And here we have a safeguard if it's like allocated or not. If the refs is less than or equal to 1, which means it's either 1 or 0. It shouldn't really be possible to be 0 here, but it's just a guard against that. Then we run deinitialize, so that basically just takes the pointer, destroys it. It also clears out the thing inside, so that we can see if we still have some weird stuff like referencing the things inside, because now they will be set to undefined. And we set the pointer to null, refs to 0. It should already be 0 basically, but yeah. Well, maybe it's not actually. Well, in this case, it could be 1. So we set it to 0, and then we destroy ourselves. So it's a full cleanup. Like you release the last one, you don't have to worry about cleaning up the actual reference counter object itself. Yeah. So basically, I run all these tests. These tests work here. I can run the tests here, and everything looks good. So that's kind of cool. Like I like this testing approach. Like when you implement something like this, you really want to have some tests to see that it actually works, instead of trying to use it like in the code. So this is pretty cool. And then you can just run zig test, and then the file name. So that would just run this like kind of like isolated here, and just this kind of unit test or whatever you could call it here. Yeah. So we could use this as a way to kind of store a string once, and then we share it around with these ref objects here, which only has like a null optional pointer in it. So it's basically like a pointer. You're basically sharing a pointer here, except it has optional as well. So it's a little bit more, and the pointer itself does have more things than just a pointer. It has the allocator, but this is only stored once for each object. So yeah. So so instead of having like these straight up pointers you're passing around, you can use this if you want. Now we have the LSP parser here, and it's saying that every time we use this resolve URI, we are not clearing those up, and that seems to be true here. Now the reference counter won't really help us here, so I basically just made the reference counter as kind of like a fun experience. I've never done any reference counter yet, so it's not really useful right here, but whatever. But here, basically, we can see here, like we're only using this to get something, and this one doesn't really care about the URI, it just uses it to get the thing. So we probably just want to deallocate it straight away here. So we have like resolve URI. That just gives us a string, but it should always be like allocated. Right, we're allocating here, so we should free it after we're done with it. So this would be like free URI. Now I guess you could use the reference counter here, but it doesn't really make sense. Like, yeah. And here we have to call free as well. I might do some fun experiments with the reference counter, but yeah. Well, now we have it at least, and it seems to work because of the tests. Okay, let's see now. Hang on, I need to build, and then I need to go here. And everything still works here. Well, that doesn't work, but import. This works. Awesome. And then we do like LSP restart. And it still fails. Is it because it fails like with... So let's check. We get it shut down, and directly after we still get more leaks here. So where's the leak? Completions. Completions 130. Okay. Okay. These are then right. This symbol is not cleaned up. Yeah. With the module matches. So I'm thinking about all stupid kind of ways you could fix this. Well, the one thing that popped up in my mind was well, I guess we could. No. I guess what we could do is, where is the thing? Like the completion, like the match. You could have a union enum here, which determines if we need to deinitialize it or not, for example. We could even have like when we create it here, really, yeah, we could have different types. We could have if we have it owned or if it's not owned. So I think that's what we need to have. I'm gonna make like owned or not. Union enum, and then so either way it's owned. Let's actually make this a function, takes a type. So either it's owned, then it's T. I guess that, or it's not owned. And then we have a deinitialize function, which we want to call, and this one is going to be self this, and we need also an allocator, and we'll do switch on self, and if it's owned, we actually need to destroy. Well, actually, yeah, we need to destroy it, and then we also need so we destroy it, and I also check. We could do. You could do this like has function t init. Then we call pointer deinitialize. Now we might need to put a allocator in there. I'm just gonna check. You have the initialize, you need allocator, right? So we'll do that. Here you can also you can check, like, yeah, it has the function. You can also check like what signature the function has. So you can actually check that if it receives an allocator, we put an allocator. Maybe it doesn't need an allocator. Maybe it even has an allocator on itself. Then you don't need to pass in an allocator. So you could do that, but yeah. All right. So and then another thing that you could do is you could also null it. So we could set it to undefined, which will, you know, this is actually helpful. I'm starting to do this more and more now, like setting this to undefined, because the values inside will in development will be set to 0xAAA. So everything, like, it will just fill up everything with 0xAAA, and then it's super easy to spot if you're using like an undefined value or not. But then in actual like release, you know, release mode, in release mode, that wouldn't happen. But you know, during development, you would kind of catch those things. Okay, so not owned, and then we don't do anything, because then we don't want to deinitialize it. Okay, so we have this owned or not. Basically, we want to use it here, so owned or not, and it is a constant pointer. So the thing here is like, let's just force this to be constant, I guess, and then we can't do this actually, I don't think, but we can do this. We can do the rest here. All right. So here, this is actually gonna be owned symbol. So that is the pointer to the owned symbol there. And technically, we could make this. We can actually do this actually. Yeah. And then set it to undefined. There we go. But if it's not owned, we don't change it at all. All right. Now this one is. This one is not owned, so we will say not owned. And the symbol there. There we go. And now we should have from symbol owned or not. We should also be able to get the inner like value here. So let's do this. And this would get us the pointer to the inner value. I guess we could do this. Get actually does a copy. And then we also have like get pointer, which gives you the pointer if you want, except it needs to be constant. I guess the other one didn't need to be constant either, but no, let's just do this. Fine. So this will just be, you know, switch, Actually, let's just use like self get pointer and then dereference it. And then here we will do return switch on self if it's owned. Actually, this would just be like an inline else. And then we get the inner, we get the pointer here. Now we just return the pointer, so because it's gonna be the same thing. There we go. So now here, wait, is it const? Oh, it is const. Okay. All right, whatever. There we go. Now here we can say symbol dot get to get the symbol, and when this is done, the completion items need to be freed, but also they need to be like deinitialized. No, wait, not the completion items. Yeah, these things. Items. I guess we'll do it here. This deinitialize. Oh, we can do it here. Yeah. So for self items dot items, we get the match. Oops, we get the match here, and we just run the initialize on it, because now the match should have a deinitialize. No, it's a function. With allocator, and we can do self symbol initialize with the allocator. And there we go. The source is just an enum, so that doesn't need to be deinitialized. And you need the allocator. There we go. Okay, there we go. Now we should have covered that memory up there. So let's go over here. We'll do some testing. Import. Oh, that was a crash. Okay, that was an actual crash there. Let's not worry about that for now. I'm gonna try doing this, and then we do restart. We still get a crash. Okay. Memory address leaked. Still we get more leaks. There was a lot of leaks apparently. Where is that happening? Azure capacity. Parser 47. Parse file. Try list append. Okay, parser 47. Right, so this list is apparently not taken care of. Now, from where is this called? Rebuild symbols. LSP document 211. Okay, it's the diagnostic list. And that comes from workspace. No, document. Oh, do we forget to deinitialize it? Okay, well, that's easy to fix. Diagnostics, deinitialize, allocator, there we go. Now, it started to become interesting to put an arena here instead. But, I just have sometimes I have like a bad experience with the arenas. Alright. And then we do LP restart. Still get issues. Shutdown, more leaks. I guess we don't really need to, well, no, we need to have it in a running environment to catch these leaks here. Unless I add like a bunch of tests that, like a bunch of, what you call it, like tests that tests the whole thing. Lexer 74. Oh, am I not deinitializing the Lexer? Perhaps. Completion. Module something something. The Lexer is where? No, this is before this. This is determined. Yeah, this like I'm never deinitializing it. That makes sense. Okay, let's try this again. Restart. Oh. More leaks. Lexer 7. Wait, still the same thing. Context stack is allocated using the, oh, it's not using, we're not using the arena. Well, okay, whatever. Let's just deinitialize it with no arena. Well, we needed to do it before, and then the child allocator. There we go. Because that would be this. That has to be the same allocator. So we're allocating with this child allocator. We have to, and the child allocator, yeah. So we can access it through the arena still, and then we can initialize them. Oh. Lexer LSP. Oh, now you need to be mutable. Okay. And you need to be mutable. Okay. LSP restart. Still issues. Where is this now? RPC. At no wait, that's array list, ensure Add one, append. It's so hard to see these logs here, because it's like wrapped in some kind of message here. Parse file list append. This again. Workspace. Okay, the diagnostics, we're not clearing them here either. So, sure, let's just add that there. There we go. Man, there was a lot of these. I guess it's good to clean it out. JSON now, okay. Types 30. This one. All right, let's see what's going on. So this should be like a leaky kind of parsing going on, I think. Yeah. What would we need to deinitialize here? The method is just copied. Over here and returned, right? So that should be... Because I'm pretty sure the client request is a parse, so that's an arena. So whatever happens in this parse will get initialized. So there's something wrong with this inner part here where something is allocated and not deallocated properly. Maybe this value. How would we deal with that? I mean, I guess we could make an arena for this and deinitialize it. This will now use arena allocator. And then here we have to duplicate. But it doesn't make sense though, because the array the allocator we get should already be an arena. So it doesn't make sense. It should already be in an arena. everything allocated using the allocator should be in arena. And this is the only place where we actually do it. We're parsing from slides. We get a parsed. This has its own arena. If you read this, parses JSON document, returns result packaged in a parsed. You must call the initialize on the returned object to clean up the allocated resources. So I don't know why it's complaining. Let's see. Inner parse. Hang on. Wait, am I not looking at this correctly? Return error missing field. Oh, we got an error missing field. That's what's happening. Okay, I just automatically thought it was an allocation error. Okay, so we get a missing field. Oh, is that for the shutdown message? The shutdown message has ID, method, and JSON RPC. So we're missing params, I guess. Okay, well, let's just set it to be a nullable thing. So now we're ignoring that if it doesn't exist. And then here, the type should be void. So then the payload doesn't really exist. Yeah. All right. If it doesn't exist, it's gonna be void. Initialize params and void. Right. Well, okay, I guess it's undefined. Instead. Whatever. Okay, so now let's see. What am I doing? Zig build. Okay, let's see if it's fixed now. That still works. Restart. Hey, it works. And this still works. Okay, cool. Nice. So restart is fixed. Let's push that up. Fixed restart bug. No, to do. Okay, there we go. Now, I'm thinking maybe this now, like keywords. That should be pretty easy to add. We could do this. We could also start working a little bit more on functions to make them more useful. Maybe. They're pretty useful as it is. Like, if we go and see what we can do now, like we can import libs, you know, of course, but let's see if we do this. And let's say we have a function. What should we do? I don't know. I'm trying to figure out. Actually, oh yeah, one thing that I really want to fix as well is like there's no way. So basically, the whole file is kind of like a function itself. I was saying like the files, like the modules are actually like structures or structs, but actually in this language it makes more sense if they are functions maybe instead. Like functions with kind of members on it, because the potentially like the runic file is actually it's executable, so you can run it, but then it also acts like a library. So I'm not sure how I want that to work. Like potentially you could also have like a different file ending to make it into a library or something, you know, but nah, because the whole thing, like if this whole thing is a function, let's say, then you would be able to call it like this. So this would actually be kind of like, well, this actually runs this script as a function, to be honest. Like this actually does run it, but then it also exposes functions and stuff in it. But when you run it, you would probably you could use this as a function maybe also. Like the thing is, like when you run the you run test rm here, you know, it imports lib, which does things, and then but we, for example, we can't add arguments right now. We don't have a way to add arguments, but you would probably want to do that because you want to have a script that could do several things, you know. So we don't have that. We don't have a way of like kind of defining this file as a function. That's what I'm kind of getting at, because you're running the file kind of like a function. And actually, like the import here is different from doing like runic, except now it should like do the same thing, or maybe it doesn't actually do the same thing. Okay. No, yeah, because it's stored in here now. The output of this is stored here. This is actually different. Like this runs the file kind of like in the outer context, but this will just run it as a script and store the as process here. So if we want this to be printed out, we have to do this, and now it should print it. Man, that takes a long time. I'm not sure what's happening there. Okay. I don't know why it takes so long. I should run some tracing on it, but yeah, it might be that my computer is doing something as well, because everything seems to be slowed down at this point. Maybe it's the LSP. Okay, I'll just restart WSL here, 1 second. I do have a bunch of workspaces up here. Maybe I should just have one. Okay, there we go. Now we're out. And I will run a WSL shutdown. Okay, and now I will launch this again. Still feels like it's lagging a whole bunch. Okay, it's a little bit faster now. I don't know. It's just my computer lagging a bit. But I won't say that this interpreter is the fastest in the world, because I have not thought about performance at all. Like, the main usage of this is just to be able to run scripts. Of course, if something goes very slow, I need to optimize it. But yeah, it's not gonna be faster than Bash. That's not the goal. The goal is not to have it faster than Bash. The goal is to have it more, for me personally, like, usable, or more easy to write scripts, I guess. Okay, but back to this whole discussion here. So basically, yeah, you can't type that out, but you can do this. I think. Yeah, you can. Alright, but... well, the whole point is, like, I don't really have a syntax for, like, you know, Bash. The Bash equivalent of having, like, you know, arg1 is 1, arg2, 2, and so on. I don't have this. Oh, the syntax is over. There we go. Like this, I don't have. So I'm trying to think about how we could do that, because that is gonna be. I mean, maybe we can have like a keyword called like argv or something. Like it could be a keyword that refers to the arguments, kind of like an array of arguments, and then you could do like array things on it. We don't really have array data types or anything. We don't even have that data types and stuff, but it potentially, I'm just thinking about the language design here. You could do that, because, you know, in a process as well, like if you're making a program, it doesn't have some kind of inherent way of getting the arguments either. Like, you have to sort of parse the string and do stuff with it, and you would have to call like is it a syscall to get you the thing, or do you get it somewhere? I forgot. but you do have to do something to get it. So it's not like you can define the thing. I mean, I guess technically maybe we could. No, I think what we would do something like this. So let's say like you get argv here, and maybe we get like subcommand is equal to argv. I guess it would be 1. Right? And then you would like, I don't know, validate subcommand and if that fails we will print usage. If it succeeds we will like run command, and then we would get like, I guess validate subcommand could yield you, we could yield some kind of thing from that. Okay, this would be like subcommand name, and then you could do something like this. You could do, actually I was thinking like redirects. So basically if we have a mutable variable here, and let's say it's called subcommand, and then it is this kind of type, the subcommand type, let's say, and then at the start it's like undefined. I'm not sure if we're gonna have like the full-on sig way of doing this, but let's just say we have a subcommand. Now this one I want to redirect standard out into subcommand, maybe even like, I don't know, reference of subcommand. I'm not sure what the syntax is gonna be, but this could be kind of cool. We redirect into this variable. I'm not sure if bash actually has this. I mean, with all the different modes and stuff it has, it wouldn't surprise me if it actually has this. But this would be a typed pipe that this function. So let's say we have this function here, subcommand takes in, I'm not sure exactly what the syntax is going to be, but it takes in a string and then it puts out a subcommand, and then we do something in here, and then this thing will be redirected, and you can see the redirection type is actually a subcommand that we put in a command. So if you try to have something else here, like subcommand type, I don't know, something else other than, let's just say this is a string, other than a subcommand, and you put the subcommand type in here. Not sure, since it's a string, maybe it's gonna get coerced into a string, but let's say it's like an int or some kind of enum or something. Now this should be a semantic error because you're trying to redirect a subcommand into a subcommand, like into an integer. So this should be a type error here. So that's kind of what I'm trying to aim for in this language. But yeah, this is how we could use, I guess, the arguments into here. Yeah. And then this function would basically parse the string. You could either, I guess, have it as an argument. You can also have it as, printf subcommand name, into, or pipe into this, you know. We could also just store, I guess, the whole arguments in here to validate, you know, you could validate args, get a subcommand out, or some kind of execution thing, and then work on that. But anyway, this is kind of what I'm thinking here, is like, this is how you would do it. Like, functions would be able to take standard in, and I'm not sure if I'm gonna have it be defined like this. So this would take a string and then no arguments, right? Because I feel like it makes sense if the arguments are empty, or the parameters are, there's no parameters, then you can't pass parameters in like this. That would be an error. But you would be able to define two types here. You would define the standard in type and the standard out type. That's kind of how I see it. But I'm not sure about the syntax though, because this could be, this is like conventionally a return type in some languages. But now we have like two types, and it will be specific to this. And this is kind of denoting like, yeah, before the actual function you have string, after the function you have a subcommand. So I mean, it does make sense. Like the notation here does make sense. A little bit. Maybe you can get used to it. Yeah. This could be a cool example here. I'm gonna do argv example. All right. Anyway, should we just do some more LSP maybe? So I'm thinking here. So basically we have completions for keywords. Let's see if we can try to make it that makes sense. LSP completions. What the hell was I doing? I was trying to, actually, you know what? I was trying to make something here, but I guess it, yeah. The thing you can do right now, you can you know, you can print, I don't know, print some kind of JSON here. You can use whatever executables you got available to you. Actually, we don't have this. I just realized. So we have to do this. And then this would be like dot result, right? Yeah. So you can do this right now. And that's basically whatever you can do with that. But there's no redirections. We don't have, I don't think we have like and, for example. Like if we do this. That doesn't work. There's no and right yet. Yeah. Anyway, let's just do this one. Keywords. All right. So, keywords. How would this work? Basically, it could be together with the symbol matches. You would have keywords, right? So this one would be, you know, symbol, the symbol mode for collecting matches. then we are looking for a prefix. We determine what the mode is, and that depends on what symbols we have available right now. I'm not sure if the keywords are gonna be symbols. Like, what is the idea there? Symbol support. Symbol options. Well, yeah, this is a completion item. No, there's not really any documentation for symbols specifically that I have in my thing here, but let's just think about it. So this determines mode. I guess if it's a substring, we have a prefix, but we don't have the actual symbol. Like, I don't understand what is the difference between prefix and substring. So if it's a substring, symbol matches. If it's a prefix, we have to start, the name has to start with the prefix. If it's a substring, it has to be an index of, so the prefix has to be in the name. So this doesn't make sense to me though. The prefix should always be like a prefix. Wait, what am I missing here? We're matching if the prefix matches a symbol. That all makes sense. If it doesn't match, we're calling it a substring. And when we actually match the symbol, if the mode is substring, is it to like do more matchings? So let's say like you do like import lib, and then instead of typing lib, I type ib. Or no? Wait, now it doesn't work. Wait, I thought that this was fixed. Also, why does it take so long? Okay, now it stopped work. It stopped working now. Now it's working. Okay. So basically, if I say no, it looks for like the first one. Yeah. Okay, I don't know. I have no clue. I don't know what this substring in business is. Again, this is AI generated here, so that's why I don't know what this means. I'm trying to understand it, but So this means that the name has to have the prefix in it somewhere, but it doesn't seem to work though. I think it meant to be like, okay, if it doesn't match the beginning, maybe it matches the end, but it doesn't seem to work. So I don't know. But okay, this should still be okay. So basically, it's like, okay, what list of symbols do we want to have? Maybe we just have like symbols, and it's a list of symbols, or it could be like an iterator. Yeah, that's probably better, like a symbol iterator. Let's just make a symbol iterator or something. No. Let's just have a list of lists. Because that's gonna be easy to just create. What's the... Oh. Symbols... Symbol lists. Symbols lists. Oh. Okay. And then here we're gonna loop through all the symbol lists. And we're gonna do that. So we call this like symbols. There we go. So now we can put in anything here. So we can make a new list like this. There we go. And we can also then, now we can put in you know, keywords as well. So I mean, maybe this could be a symbol. Maybe the keyword is a symbol, like a workspace symbol or something. We could just put it as a workspace symbol. So let's just have, we'll do like keyword symbols. It's gonna be a list of symbols, symbol. So we have like detail, kind, name. Detail is gonna be, this is just gonna be like keyword or runic, I guess. Maybe, I don't know. Documentation, sure. And then we have like name. Wait, documentation is what type? Yeah, it's just a string. Name is something, and kind is a keyword, I guess. Yeah, that does exist. So, but this kind is this kind, so we just add keyword there, and then it's automatically like it's automatically translated to the other one. Okay, and then now we just have to do like name and word. So I think I'm gonna do like make keyword name and documentation. and this will return a symbol. Right. So now we can just say like make keyword, and we have name and documentation. All right. We have to put them here as well. All right, so now we're making a bunch of keywords. So we have like import a runic module, and then I guess we could have like I think you can do this to embed code. Okay, and then we have like I don't know, const, define a constant, mute, no, var, define a variable, and this one we could do runic, what else do we have? Function, declare a function, hello, Alright, we do have a bunch of keywords somewhere. Where are they? Let's copy these. I guess not all of these are gonna be here, but okay. These two we can delete if, yeah, we don't have a bunch of these. I'm just gonna do this then. Import return match file for it. Yeah, fine. All right, let's start there. So we have the keyword symbols here. So let's go here now. So we'll do guess this will be a try now instead. Yeah. I mean, technically, you don't have to do it. We can have like the symbol slice. This could include it, include the symbols. However, actually, we could return a list of lists actually. That we don't have to do all this crap. Yeah, that makes more sense. So we return a list of lists, because then we can say Actually, we maybe can't. Because the address is going to be here. That doesn't work. Unless we make an iterator. We can make an iterator, but that's too much work right now. Let's just do this. Fine. Workspace. This is arrowable. Return workspace. Now we have to say this so it knows the type. And then we do index, pen slice, allocator, items is keyword, symbols, try. Alright, now we should get an error somewhere here. Here we have to try now. You are now errorable. And we do try here as well. Alright. Change the type there. You need to be that. There we go. Okay. So now that should be included in the workspace. So technically, this should be now included in the symbol thing. So if we go here, restart, crash, and burn. Restart, build. It crashes. Why is it crashing? Invalid free. Okay, let's make this into a function. We take an allocator. We will return this type. We will return alloc. Whatever, let's just do it the easy way. No, not the initialize. And then we will this feels super stupid, by the way, but whatever. We don't have good utilities to work with this right now, so I'm just gonna do it like this. Actually, maybe we don't need to make this thing. Maybe no, maybe we do actually. All right, and then you're a try. You need to be you. There we go. Now all of these need to have allocator. And we need to also call everything with like list append. It's not as clean. No, wait. No. We'll do keywords is that, and then we just do one. Whoops. No, let's just do try append slice. There we go. That's a little bit better. Yeah, you're a function now. Array list. You are. Everyone needs to be try. You need to be called, and when it's called we also need to like, okay, keywords is try keyword symbols, allocator defer, allocator free keywords, and we transfer it there. I guess we could also just have an array list that we appended into, but whatever. There's also maybe a lot of other ways to do it as well, but that's like way cleaner. Yeah, we're gonna work with what we have right now. So let's go here and test import. Okay, this works now, but we still don't get these like const for. I mean, maybe there should be snippets, but let's check here. Receive message. Completion. Next token contains sent JSON. Yeah, empty thing. Why? So we should be here. All symbols, and here we do like for all symbols, try to append that. There we go. Okay. All symbols. Oh my god. Why can't we unable to resolve comp time value? What? What is going on here? Oh, it's the type. I think we have to sort of say that this is a type of const symbols dot symbol. There we go. There we go. Alright, but that was basically not really fixing the issue. I'm just refactoring here. What is the issue though? The workspace symbols doesn't seem to be matched, I guess. So let's see here if we can see trying to match against symbol, basically, like trying to match and then this would be like prefix against and I guess this would be, well, okay, you can't say that, we have to say like prefix and then entry name. So then we would kind of see, okay, which ones they are, it's trying to match it against in the logs. So let's go here and we'll say that, and that should trigger it. So trying to match const against lib, that's the only thing. Why is it doing only that one? Completions. So basically, yeah, it's just the symbol list is like empty. Is that's what's going on, I guess. But why? Did we add them here? We take the keywords, we append the slice into index. Because the array list should be copyable, I'm pretty sure. Unless we don't call this function. And we are calling the function. Handling completions, collect matches, workspace symbols. Let's try to do it here. Log error workspace symbols, and I will just say how many it has. Length, because this just returns index items, so. Yeah, that should work. Workspace symbol 0, yeah. So why is it 0? Empty, we append the slice into list. We append all these things. We return this. Right? and we get this out. Keywords, symbols list, keywords length, workspace, symbols list, workspace, index length. Keywords, symbols list 4, workspace 4. Zero. Why? Like, is it getting overwritten or something? By these goddamn allocators. So at this point it's correct, right? We return. Okay, let's actually. What is this weird thing? Why do we? Has that always been there? The 2 dots there? No, no, they haven't. Why? There's a ghost in my machine here. Okay, I will do this after we return it. I want to know what it is. It still says 4 here, okay. And then you say 0 still, okay. So at this point it's working. Wait. At this point it's working. You are being called from here. And then we run it. And we handle the thing. If we have like initialize, we do a whole bunch of stuff. Reset roots. Refresh. Clear index. I see. I see. Okay, let's. It makes sense. Let's make a function like add keywords to index. So here, like, or not public, but add keywords to index, workspace, index, no, keywords. No, we get the keywords here. So we get the keywords, those keywords. There we go. And then we should have self-allocator as well. There we go. Now we can, instead of doing this, we can do workspace and keywords to index. Alright, and then over here, I guess we probably don't need to do it since we are calling refresh the first thing we are actually doing for some reason. So technically we could probably get away with it, but whatever, let's do that anyway. Hey, and we get this little thing, except it doesn't really work. This part here, I'm gonna change this to be something else. So let's do where was it here? Let's change this to like keyword maybe, and then let's change these to be runic. And that. Not sure if you need like the ending new line there, but whatever. Oops. Const. Well, okay. The thing doesn't really work, but whatever. At least it doesn't show. Okay, and then we have like var, define a variable, import a runic module. Function, declare a function. It would be cool if we could implement like full-on snippets with these things, but yeah, that's probably a future thing. It's probably not that hard. Implement basic snippets, const var function. Whatever, it's not that important. It's just, it seems like such an easy thing to just add for convenience. Okay, so we have completions for keywords now. Cool. Now I do want to check the match thing. Where's the completion item? Here, because there are things you can say, like documentation is a string or a markup content where you can specify the markup kind, which can be like I think it could be markdown maybe. Describes the content type that a client supports in various results. Please note that markup kinds must not start with a thing. Okay. That a client supports. I thought this was like server. Okay, yeah, so markup kind markdown, which we don't really have, I think we need, I want to change this into an enum that will fix this issue. I just need to check the documentation for the specification. So let me do that. Here's that. And we should have like markup kind somewhere. Here we go. So it can either be plain text or markdown. I'm gonna make this into an enum, and we'll make like a custom JSON formatter instead. So let's make this. Although it kind of is implied that it could be something else, though. Describes the content that a client supports in various results like hover, parameter, info, completion item. Please note that markup kinds must not start with a $sign, but there's only like plain text and markdown, so I'm not sure why they say this here. This seems more like a note to the developers of LSP specification. I don't know. Or if the client has some kind of weird thing. But I'm just gonna make it into an enum that has both of these. Okay. Hello, Machete. Yes, I'm Swedish. How did you know? Let's make this into an enum, and we have like markdown or plain text. All right, now let's make this. Let's make a JSON parse. Yeah, from value, sure. And also JSON stringify. All right. So stringify should be pretty simple. It's just going to be the tag name, actually. Stringify write or writer. No, actually we could do write and then tag name self. Here. So that will basically write it as a JSON string, because this is a string. It will write it as this JSON string. Here we will just match it with this enum name here. So we will read a string, or actually wait, yeah, we say that this is a string, so we'll switch on that, and if it's a string we get it out here. Yeah, that's the actual string. So now we just need to match it with this, and there's a built-in, or not a built-in, but there's a standard function here called string to enum, and the enum is markup kind. Actually, I'll just use this because then it's more generic code here, and then I can do s. There we go. Now if it's something else, I'm gonna try and find a matching, maybe invalid enum tag. Sounds pretty good, right? All right. Now we don't need the allocator, we don't need the options. Perfect. All right. Now I'm also, for safety, I'm gonna implement JSON parse as well. And here I'm just gonna first parse it. You need these things, and you need to be a parse error. There we go. First we need to get the value, and then we just return no, we just return JSON parse from value. There we go. Except this needs to be value. There we go. All right. Now we've done this. So basically, this is kind of super generic code actually. This code here, this would work on any enum that has this kind of structure where you're converting a string into an enum where the tag name matches exactly the enum that you want, or the string, yeah, where the string that you get in matches exactly the names of these fields here, or tags, I mean. All right, so now all of a sudden markup kind is not a string anymore. It should be an enum. So and then if you want to support other strings, you can just add more here. And when it gets converted to JSON, it will be converted to a string, which is the tag name of the thing. So it should all work out here. All right, now the markup content. So where do we actually handle this? I think if we go to LSP server, handle completion, we send back the completion result here, and the item is from symbol, and here we can see the documentation. I'm always gonna say that this should be a this should not be just a string, this should be a markup content where the kind is markdown. And what else did we have? Wait, yeah, here, value. Yeah, okay, value is that. Markup content, payload, and should be like that, right? And I will do maybe this to get some kind of structure there. Okay, so now all the completion items should be reported as markup content instead. Or not. Or maybe it is, but there's something else wrong. Diagnostics, no. Where's the completions? Here we go. So documentation is a kind, markdown, value. Maybe it's because Runic. Maybe it's because it doesn't work with Runic. Maybe. I mean, what if we try something else? We tried, because I thought it was gonna work, because NeoVim. I mean, you can see here the markup or the formatting for Runic is implemented here in Tree-Sitter. So I thought that maybe Markdown would kind of grab whatever's in like available in NeoVim. I'm not sure actually how it works, but maybe there's something else that works. How did you learn to do all this? Hello, Rokutiki. I've been programming for a long time, and yeah, I'm passionate about programming, so I'm constantly trying to learn and improve. That is the boring answer. I mean, yeah. I'm not sure what you expected me to answer, really. To be honest. But if, I mean, if you have a more specific question, like about the LSP, or do you mean like making a language? Because I mean, yeah, it all boils down to just, you know, if you want to implement an LSP, for example, just, I mean, you could just go ahead and, as long as you know how to make it like a server kind of thing and work with JSON and make a program, you could basically just make your LSP, your own LSP. You just have to read the specification, and that's it. When did you start programming? I started learning programming 30 years ago. But then with like, then I was like very young, so it doesn't really count. Like I have 10 years of working like professional experience, but before that I already knew, you know, how to program and everything for a long time, and had it as like a hobby for a long time. Okay, well, I was gonna try doing this. So let's do workspace. Let's make it like const. Yeah, let's not make it runic. Let's make it like, I don't know, TypeScript. Or I should have made it zig actually. Now that I think about it. Import. No, it still doesn't work. Okay, well that's good. To some extent. Is it formatted wrong or something? Markdown is just a markdown in one string. Wait. What is this? It says here the value should be a string? No, okay, it's joined by, okay. Are you also, do you want to learn programming? Rukituki? So that's basically what we have. I mean, okay, let's try to do some other markdown stuff. So let's just add like, I don't know, a import. I want to see if LSP restart works here. It does work, but you can see here that this actually doesn't work. Why is it doing that? That's weird. Well, okay, I mean, I guess it's like doing it in a terminal kind of way. But why does the embedded script doesn't work? Oh no, this is runic. Okay, let's change it to zig. There we go. So it should work, but it doesn't work because yeah, the markup doesn't really work. Because this is like file type runic, right? And I thought that it would like embed the thing in there. New Vim, LSP, no, well, markdown, embedded, syntax highlighting. Markdown fenced languages. Okay. So apparently we have like somewhere maybe in there. Okay, let's actually go there. Let's go to like here, and we'll go knockdown fence. No. I'll just add it here, I guess. G. Will this actually work though? This feels so plug-in-y to me. It's an option in NVIM tree sitter. Ah. Oh, and I have it there. Tree sitter. There we go. This is weird, though. Like, do we really have to whitelist? We've been learning for the past few months. Want to make some projects now. Oh, really cool. What kind of projects do you want to make? Can you extend? I think you can do like Vim. No. Table. Extend or. Concat. It should just be a list of strings. I might be messing something up here. Zip? What? What the hell is this? Oh, it returns a string? Okay, this did not do what I thought it was doing. Wasn't it something like deep extend or something? A function. Oh, deep copy. No. Insert. Insert an element value position. Okay, let's try. Let's just do insert, I guess. So we'll insert runic. This should really be like maybe in runic then, like in it runic, but whatever. Bad argument. Oh, I see. Okay, so if this is nil, you could do or this, right? Yeah. Hey, now it works. But that's stupid that you have to do that. Yeah, okay, this is like TypeScript, so let's, it was in workspace. Yeah, let's change this back to Runic. Wait, did it work or did it not work? Because they were Zig and TypeScript, so it doesn't work. Oh. God damn it. Maybe I have to do it like before. Okay, whatever, that's the same place. Where did it go? Oh, this is the... It's the wrong place. Did I do... Wait. I thought it was sim-linked. No, I've messed about with my NeoVim config recently, so... No, this is definitely the one, because it was an error before. Yeah. So what if we set... No, that doesn't work. Three-seater... I wanted to move this maybe up here so that it's set before, but it still doesn't make sense to me because it worked like for other languages, so why would this be different? Maybe it's like some sort of built-in thing, I don't know. New. Alright, I have to do this here. No. Wait, it doesn't work for TypeScript either. What's going on? Okay, now it's like stopped working altogether. Now it works. that doesn't work. Oh wait, I think it might has to do with I need to like load a runic file first. Okay. But so why doesn't it work here though? Why? So backend related progress using Spring Boot. Oh, I've never been in that world. Like, well, I've done a little bit of Java, but I don't think I've ever used Spring Boot. It was always a mystery to me. Okay, well, it's not the end of the world. It was just a little bit annoying that it didn't work. Okay, let's go back here. So we have keywords basically. I'm gonna write down like a bug there. This works, but there is a bug. Markdown. Markdown syntax highlighting does not work for runic. All right. Well, I'll just leave this bug. Actually, you know what? I can tell AI to do something about it. Investigate why the runic. Actually, it should probably be in the Neovim project. Runic syntax highlighting does not work for like LSP completion item documentation. Yep. You go do that. Okay. Now let's see. What do we want to do? Member access. Maybe member access would be kind of cool to have. Although I'm not sure. Like member access. How would this work? Like you would know. You would need to do like. How would that work? You would basically need to like load a module. Like it depends on the kind of object. You would basically need to start to get all the AST information, and also even like scopes and stuff in there. Maybe. So that, yeah. But maybe for modules it will be kind of. That would be kind of the same kind of symbol completion, but for that module. So we can load in the module type. So basically like this. You have this module here, right? And if we go here, we have all these things in here. Now in here, we get these, you know, auto completions, or we get these completion items here. So that's fine. But here, this doesn't work. Okay, you get this. This doesn't make sense though. Yeah, that doesn't make sense. But okay, I'll write that down. Bug should not get keyword completion items if matching with a member access expression. All right. And also, actually, this is kind of, well, I guess this goes into member access. I mean, yeah, it goes into the member access because completion items, because when we have support for member access features, or I mean completion items, it will actually see that, okay, well, it's a dot here, so we are supposed to use the member access algorithm, and then we can just do away with all the keywords. So really, this is gonna get fixed when this is actually implemented. So so we don't really need to worry about that for now. But let's see here. So when we do this, imagine then here. So this would now have to, what we could do is see that, okay, this is, we don't actually know that it's, we could kind of hack this like we do with the tokens to see that we actually have a symbol called lib, which is in a module, but we don't have semantics right now, so we can't actually see that this is supposed to be, I mean, we could do the AST and see that, okay, we have a binding to a module. Maybe we could even execute it to some extent, because then we would have an actual binding in a scope that we could use. So I guess making completion items is like partly what you need is like, or what you need is kind of like a partial executor of the script or more type information. So, and that's what we don't have right now. We don't have type information about these things. So we know that we have something, and also we don't have like scopes, I guess. So we don't really know. We have the outer scope, I guess. We have like the outer scope because we're kind of collecting these symbols in the outer scope. So that's how we know we have that. If we go in here, for example, and we're trying to do stuff in here, we do have name, but if we try to type again, we also get again. However, if we do something else here, ASDF, we don't have. If we put ASDF down here, now all of a sudden we get the ASDF, but it's because we're only looking at things in the outermost scope right now, because it's a very, very basic implementation right now. So what we need is we need to have some sort of scoping system. For example, things in here should be scoped to the function. And right now we don't really have closure, so you really shouldn't get like things from outside, but when we do, we should implement it. Yeah, so there's a lot to think about there. Like, I didn't realize like adding LSP support would potentially have a different kind of execution workflow maybe than, or I mean, yeah, different, like, you know, collecting the symbols and stuff. Like, you would need a whole machinery around that specific thing as well. It makes sense though if you want to have like a lot of stuff in the code base and you want to have it like super optimized for that purpose. That does make sense. But this is going to be very, you know, simple scripting language. You're not going to have huge scripts anyway. You know, you're not going to have millions of lines of code in this language. It's just going to be tiny bits and pieces of runic, you know, things. And then the libraries, you can have libraries and stuff, but it's probably not going to be that much stuff. We'll see though. If we need to optimize, we could optimize. Anyway, yeah, so you can see kind of like how the issues crop up here when we don't have support for certain things. So it's gonna get hard to actually implement this member access without having these tools available to us. So I think we'll have to put this off for now, and I will say like need some sort of scope, you know, scope machinery around collecting symbols and stuff. You know, very vague there, but we need some sort of way to be able to more easily be able to know, okay, this is the scope of the function, this is the scope of this module, and also we need as we also, and it would help a ton with type, like semantic analysis as well. So right now we have like lexical analysis with turning things into tokens. We have syntax analysis with the AST, but then we also need semantic analysis, and that's gonna be like the types and stuff. So, and once we have the semantic analysis, I think it's gonna be way easier to do these kinds of things more easily. Because right now, if we could do this if we want, but it's going to be a very hacky implementation, and I don't want to like do that job first, because that's going to get thrown away once we have the semantic analysis. So that I don't want to do like the double work there. All right. Okay, so what can we do now? I mean, I guess we could start working. Maybe we could start looking at the type, like the semantic analysis in that case. So I think in order to make this, in order to implement the tools needed for this, what we need is two things. We need the tokenizer, and so we need a lexer and the parser, and eventually the type checker or the semantics analysis thing, to be able to partially construct their results, even if there's some kind of parsing error or token error or semantic error along the way. We still need to be able to construct a result that we can use later anyway, because it makes it more robust. It makes it so that, you know, if you go in here, I can show you an example right now. So let's say we have a function hello, and we echo hello, right? But let's put in some kind of error in here, like just a number maybe. Oh, is that not a... Try to restart. No, apparently that's legal. What if we do this? Yeah, see here? Now we get an error here. Okay, but then we do this over here as well. We see we only get one error. There should be an error down here, but we don't get it. If we delete this, now the error is down here. So it's because the parser just quits at that point. It runs the thing, but then it just aborts whenever there's an error. So we need, or even the tokenizer, it's also gonna, like if we have a token that doesn't exist, that is also gonna be blocking the rest of the things, you know. So basically what I want to have is, I want to sort of, I guess we'll separate the code in pieces that are kind of on their own. That they could be maybe analyzed on their own. Perhaps that's going to be more complicated than I first thought, because we can't just do line by line. The thing is, like in here, this is a different scope. Like this is in the function. So here, this follows like different rules than this outside, maybe. I don't know. Yeah, so that is one thing that we need. We need to be able to get all the errors, or as much as we can, without this like just failing and aborting everything. Because if the lexer fails, the parser will fail, and the semantic analysis will fail, which will cause, you know, things to happen like let's say I want to, you know, call this hello function. See, it doesn't get it because there's an error here. If I delete the error, now I get this here. But it really shouldn't, this shouldn't really prevent us from getting this function because so what's happening is basically it just throws up its hands in the air and says, hey, nothing will work here. We can't even do const, or I guess we can. Okay, we can do those, but we can't get the symbols here. So we don't get lib, we don't get hello, we only get the built-in stuff right now. So that's one thing that we need to fix. It's not trivial by any means. It's probably gonna be pretty tricky. Now I could tell AI to try and fix it though. I could ask AI to kind of investigate, give me some sort of report on what some ideas on what we could do to implement it. I don't want to ask AI to actually implement it by itself, because then it's probably not going to be great, or what we want, because it's kind of it feels like you can do it such many different ways. So I'm just gonna ask. I think I'm gonna ask AI to like, hey, could you give me a couple of suggestions or something on how we would approach this problem here? And here are like the requirements that I want to have. Okay, that's one thing that we need. The other thing that we need is trying to find it in my mind here, because I was rambling about the other thing. So the first thing is the not aborting the whole thing because of one error. The other thing is the type checker, semantic analysis. Yeah. Maybe we could start on the semantic analysis. I've never done that. That's the thing. Like, and the AI actually did. So there are some, you know, type checking stuff here, but I don't know really how it works because I haven't looked at it. This is all AI here. Hello, not Slider. Long stream today. I'll probably stream max 3 hours more. We'll see though. I'm starting to get a little bit brain dead already, but actually maybe we shouldn't start with this, because maybe we should do something more easy here. I'm not sure. Yeah, because this is gonna be a lot. Like the things that we have on the to-do list right now that I'm thinking about is like very huge, heavy stuff. We could also work on functions, like the actual functionality. Are you sure you want to? What is that? Vicent. We could also work on functions. We could work on closures, because that doesn't seem like a super hard problem actually. We just do like, we just copy the scope and put it in the function. Make like a clone of the scope. SEMA. I don't understand. Okay, there we go. Semantic analysis. I mean, I think so. because the cool thing is if we could get something like this, like, okay, I have the example here. Where did it go? Where did it go? Where did it go? Yeah, here we go. argv example. So here, for example, I was thinking because each runic file is basically kind of like a function as well, like a runic function. So we can take arguments. So it's like, okay, how would you take arguments in a runic file? Well, of course, every other program uses argv, so we can also use argv. Now this is of course gonna be like a string, and however, oh yeah, you know, normal runic functions, you can have typed arguments. Here they are strings, but I'm thinking maybe we can have a syntax where the argv's are actually, you know, you say that, okay, well, this is supposed to be an integer, for example, because then you could say, you know, if we say it's not source, maybe, I don't know, call some kind of keyword and then other runic, and then you would be able to pass arguments to it, but they would be or maybe even runic, but they would be typed, you know, so you could pass like typed arguments to other runic files so that it would be typed. But that would be kind of cool. Anyway, that's one thing. The other thing that I'm showing here is basically that the pipes themselves, or the pipes, you know, these things, the pipe stages, can have typed inputs and outputs. So let's say this validate command, subcommand, takes in a string in the standard in. So this is the standard in. Validate subcommand. It puts out a typed value, which can then later be used. I mean, let's say you have another function that is like run subcommand, which takes in a subcommand and then you know, avoid whatever, does some side effects. Here I'm kind of showing how like we run the subcommand, but if we do the same thing here, and then instead of doing this, we will pipe it into run subcommand. So you basically have a typed pipe here. So you would, this outputs a subcommand, this takes a subcommand in the standard in, right? So you would be able to do something like this, because the thing is, I want to keep sort of the syntax familiar and not try to invent a whole bunch of new syntax for these kind of things. I want to reuse the same syntax in order to do these things. So that would be kind of cool. Now, and then if you know, if this would be something else, like let's say a string. Now this is going to be a type error, or potentially a warning. You know, if you have like coercion to string on, maybe subcommand is one of the types that doesn't coerce to a string. But you know, you get what I'm saying. Normally this would be like but let's say this was an int or something. Now this would be a type error here. So you will have like, you know, because the types doesn't match. This gets a subcommand, but it was expecting an int. Okay, now the other thing you could do here is this thing, where you would have the redirect operator, and then but the redirection goes into a variable. So we redirect the output of validate subcommand into this variable, and that's also typed. So you have typed like redirect there as well. So yeah, that would be kind of cool to have. And then you have like the usual kind of, you know, bash like thing here, where if something fails, we can print usage and then maybe exit. You know, if let's say print usage was here, and then this would like echo usage blah blah blah, and then maybe we have like, I don't know, exit 1 or something. So function calls, like the syntax is gonna be pretty, you know, pretty consistent is what I'm looking for. I'm looking for a consistent syntax. Function calls will never look like this. Like, it won't look like this. Function calls would look like this. No parentheses. It's probably gonna trip up some people, but some functional language, or yeah, Haskell does it like this. I mean, Bash does it like this, and we're trying to replace Bash here. So Bash and Haskell actually has some things in common. There's a lot of abbreviations there that I don't understand, but all right. So yeah, so that would be kind of cool, and this is why I want to have semantic analysis. Also, because I've never done semantic analysis before, so it's gonna be an interesting learning experience as well. All right, what can we do? Maybe I'll jump on closures a little bit. Sure, let's see if we can fix that. And that would be kind of, I think that's gonna be the last thing here actually, because I'm starting to feel a little bit tired already actually. I'm not sure if I've got something coming on or what, but let's do closures. All right, so we should have, where do we do this? Like evaluator. We should have like a function ref somewhere. Function ref. Now, okay, so this is a reference to a function which has the function declaration that includes all the code that we need to execute for the function. We also have the scope stack, which is the scope of the module that the function is in. But we should also have a closure, or yeah, okay. There's two things. The scope is used to be able to access, I think it's used to be able to access the function itself, I think. Yeah. So this is kind of quirky how this works, but this is needed in order for the pipeline runner to know if it's an executable that we want to use or if it's a function that we use, because it does a lookup on the scope to see, okay, is it a function or is it a you know, and if the function doesn't exist in the scope that you're passing in, then it tries to execute it as an executable, and then you get a file not found error. But so we need to pass the scope where this function was defined, and then we can access it from there. Now the closure is different though. The closure is gonna be kind of the scope of the actual like execution of the function, where it would have access to whatever values was available at the time of declaration. So it's gonna be basically when a function gets declared. So it's gonna be like evaluate, no, execute function declaration right here. So here we're executing a function declaration. It's basically when you encounter a function declaration, this gets executed, and we're producing this reference value, and we bind the name of the function to an identifier with this function reference value here. And here we need to capture the scope. Capture scope into a closure. And then add closure to function ref. And then when executing the function, it's not going to happen here, it's going to happen elsewhere. Happens elsewhere. We need to execute the function with the closure. Include closure in scope. Execution scope. So I think these are the three things that we need to do to implement closures. So it's not that, I don't think it's that hard, to be honest. I mean, I guess I could be eating my words later, but we'll see. 3 hours later, we're still working on this. Like yesterday. Or wait, was it yesterday? No. Yeah, whatever. And some time ago. With the, what was it? Yeah, the completion for module imports. That took a while. All right, so capture scope into closure. So it's gonna be this scope here. Now we're basically gonna do some kind of cloning thing here. So I want to clone this, and that's gonna be the closure basically. It's gonna copy like all values, everything in there, put it in a new scope. That's the closure. So it's kind of freezing this into another scope, you could say. Okay, so we need the clone method. Okay. What? Okay, whatever. We need the clone method. We need to put the closure here. This is so weird. Like when I try to do like go to definition, it says no client attached. But then I do go to type definition and all of a sudden it works. I have no idea why it does that. Okay, closure. This is also going to be a scope stack. Yeah. I guess this would be a try. There we go. So now we have done like A and B, except we need to implement the clone function as well. And then the third one would happen when we actually execute the function, which happens elsewhere. So that happens down here when we run the function as a pipeline. And we're storing. Do we store the function somewhere here? Maybe don't. Maybe we don't. We only store the name and then we pass in the scope. And the scope is the function scope. Okay. So this should really be like the closure, really. Yeah. So this should be like the closure, but then we also need the kind of function, the scope in which the function is declared, function declared scope. I mean, basically we just need a function reference at this point. And now we evaluate the pipeline. Okay, so we have to embed this information here. This is actually supposed to be the execution scope. But then we need a closure as well. So let's do this. Let's change you. So this would be like the lookup scope. And then we'll have the execution scope. So the execution scope is going to be the closure. It's going to be whatever, you know, variables and stuff is going to be changed in the execution scope. The lookup scope is going to be how to find the potential function that you want to call. Now, instead of doing the lookup scope, what we could do as well is change, where is it? Is change the type of this so that we can actually just store the function reference here instead of having like a text name and stuff. But we don't always have that, I don't think. So yeah, that's what but that's gonna change when we get like the semantics in, because then we will know if it's a function even before running it here. All right, so let's see. Yeah, evaluate pipeline. So we have the lookup scope and the execution scope. The lookup scope should already be changed here, yes. And here we actually get the ref. So maybe we don't even need the execution scope, to be honest, because we get the ref here. So we could just use that. Yeah, okay, so let's... But I still want to call this the lookup scope. That's a good name for it. All right. And then what's happening is we run it. God damn it. We run the pipeline. And yeah, okay, so then we have like run stage. Run function as pipeline. Oh yeah, we just put F there. Why is this not working? What is happening? Oh, hang on. No, it does work. Okay, now it works for some reason. Okay, cool. Okay, it's way easier to move around now. So we have this here. We have run pipeline, run stage, run function. Here we go. Okay, whatever. So we got our function ref. We're running our function. We should just take the ref here, to be honest. Let's just take the ref instead. All right. Okay. So we got a new frame. It's blocking. Or we could say we will work with the closure except how would this work? What if you have like a mutable? Okay. Let's say we have a mutable a equals 5. We have a function that's add 5 to a. That takes nothing. Okay, this is not actually the syntax right now, so I'll remove that. Then we'll do like a plus equals to 5. Well, I don't think we have plus equals. I don't think we actually have this syntax here either. No. Unexpected token assigned, expected tokens. Okay. Well, we have to fix that as well, I guess. Yeah, LSP, no, to do functions, expressions, arithmetic, and assignment, reassignment. All right. Anyway, the point I'm trying to make is, what if you call this function and then, yeah, now this should change like in the outer scope. So, and then you're trying to like echo a, this should echo out 10, right? At this point it's 5, and then we add again, this should be now 15, right? That should be the expected thing here, right? This is going to be like a reference. Like if you're calling this function, it's kind of capturing this as a reference, right? Because it's mutable. So maybe we don't actually clone the scope. No, but we have to clone. No, we clone the scope, but so okay, next thing is we have another function called add 10 to a. How will this work? I mean, I guess this would just be like 25 now. But then that doesn't work if they have separate closures. The closure has to refer to the original variable. Like as long as it's a mutable, it should be like a reference that you get in the closure. And then also like here, if we change A to 10, will that affect the A here? I guess it would. And that means that we basically just could use... Could we just use the same scope then? So when we push when we execute this function, we don't need to push a blocking frame. We can just push a normal scope, because then it would have, as long as it's operating in its own closure, it should be able to. Yeah. Okay. All right. So it was a little bit more thought process we needed to do here. But basically here... Okay, actually, let's go back then to like evaluate expression. And we're running the... execute function declaration. So we don't need to clone the scope actually. We just put the scope here. Yeah, that's the actual scope, and then we don't actually need... No, that doesn't make sense. Because then, okay, this particular scope stack, it's just that when we clone it, okay, because this scope stack can get more scopes on it and they could be popped and all that, so then it disappears. We need to capture the scope, but when we clone the scope, we need to like create references to the things in this scope. Or do we? Man, this is braining right now, because if we pop a scope here, it disappears. We need to like we need to keep the scope, right? Doesn't this disappear if we pop the scope? That's when the execution disappears, like from the module, for example. Yeah, I think in terms of this, we need to like clone it. Yeah, we will have to clone it. What about then functions sharing variables like that? They would have to have a centralized place where the variables are. They would share that variable. Aha! And this is where we could use reference counters. For example. Yeah, we might be able to use like reference counters to actually deal with this, because then we don't need a centralized place to have it. We just need a reference counter that we use. I mean, we have a centralized place in terms of having an allocated memory for the thing, but we would know when it's no longer needed, basically, I guess, when the yeah. That could be one way of solving it. Okay, so this wasn't as easy as I thought. I was a bit naive there. All right. I mean, if we want to have all these features that I'm talking about, like if we want to have this thing here, unless we just say that, hey, this is just a copy of A at the moment where this was declared. So A is always going to be 5 whenever you call this. You know? And then if you call it again, it's going to modify the A that this function has. And then this function is going to have a separate A. It's going to have a different A we're talking about. But I don't think that's what we want. I think we want to have the behavior we're seeing here. They're gonna share the A. Yeah. Okay, let's do this. We have a reference counter here, but it's in the LSP. But however, it's not used, so I'm just gonna move it or copy it, maybe even to like Runic or no, I guess I'll just copy it here. I guess we can make like a memory. Thing. All right. There. Let's put. No. I'll expose those. Wait. Yeah, okay. I was like, is there something magical about the root.zig? But like in TypeScript, for example, if you have like index.typescript or index.ts, you can actually just import you know, or it would look like this. You would import the actual folder or directory, and then it would auto check, like it would auto append this to the import. So if you have that, but I was thinking maybe root.zig has something similar, but it doesn't. Okay, so now we have that. Now we can say I guess maybe we could have a special kind of function for closures. Maybe we could do closure. We can create a new closure, and that would have a special thing. And then the closure could okay, maybe if a variable is mutable, we create a reference counter for it automatically. Maybe. declare mutable we could make this into a union enum then. A binding could be a union enum. Excuse me. Because I think like we need two different things. Like if it's a constant, it just has a name and a value. If it's a mutable, it needs to be a reference counter, I think. Then we have binding ref as well. Look up. Oh, okay, that's just a reference to the thing. Or we could keep we could keep like name and no, let's do a union enum. So we could either have a constant, which is gonna be a struct with name and value, or mutable. Because this is never gonna change. Like you're not gonna be able to change, you know, the mutable property of a binding. It's always gonna be the same. It doesn't make sense if you could change it, because then it doesn't mean anything. It feels like. Okay, so this would be like name, but the value is going to be a reference. No, wait, this whole thing is going to be a reference. Counter thing. So we'll just remove is mutable here. And this is gonna be, let's do like reference counter import that. Yeah, we're gonna get a whole bunch of errors from this, but let's make this type a little bit more easier to work with as well. So mutable, so this will be like a reference counter. Actually, it's gonna be a pointer. And the type it's gonna store is this type here. Now, why is name like mutable? That I don't understand. It shouldn't be. You shouldn't be able to change the name of a binding. That doesn't make sense. Import mem. All right. So what is happening here? Like we're freeing the name and deinitialize value. Why this should just be a deinitialize function on binding itself, you know. Now, since this can be a reference counter, and the reference counter, when the reference counter is kind of released, it can return an error. So this is now also an errorable. This could be an RC error. Because what's gonna happen here is we're gonna switch on self, and we're gonna get either, if it's a constant, we will just try, and we need allocator as well. We will try to, no, not try, we will just free the name, and that's it. No, that's not it, sorry. We will also, oops, we will also do c.value.deinitialize allocator. All right. I think we need to adapt RC a little bit, but in order for this to work, but we'll see how far we get here. So if we have a mutable, we will also free the name. No, wait. What we do is we say mutable dot. Wait, no. This is a ref. This is actually a ref. Yeah. This is a ref. That's how it works. We're storing a reference to the RC, because the reference is it's kind of keeping the RC within it. And then when you release the ref, it can go into the original RC. It will be able to, decrease the ref counter. And if the ref counter is up, if it's empty, then it will like release everything in it. So it's like a shared pointer here. The ref will. Have the RC. When you release it, it releases it by decreasing refs by 1. And then there's some safety checks as well here. And when if the refs is like, if this is the last reference, it will deinitialize, which means it will it will set the content to undefined. It will destroy the pointer. It will also destroy itself, like the pointer to the reference counter itself. So that's the shared like thing there. Now what's kind of missing here is this like deinitializing the actual value itself as well. Now maybe what we could do is return either kind of like a bool here, or we could return the value itself, like a nullable value. If we deinitialize the thing, we return the value itself. So you could potentially do cleanup yourself afterwards if you get it. If it's null, it means you don't need to clean it up. But that needs, then everywhere you call release, you have to do that. So that's not good either. What we could do maybe instead is have some sort of interface on T, which is like, okay, we check if there's a deinitialize function, we will just call it. So basically here we're saying if has function deinitialize, we will call the initialize, and also we probably need to pass in the allocator as well. Okay, so we have, so now we're calling the initialize if it exists. We should properly clean the value up as well if it has like other things it needs to release and stuff. And yeah, and here's like the init function. We can provide the constant like initializing value, put it in the RC, and there we go. Okay, let's see if it works. I have done a lot of tests on this, like these tests here, but I haven't actually. Maybe I should add a test for like calling the initial function, but we will notice it. But also, if something gets leaked, that's gonna be reported as well, so that you don't miss that either. If you miss to release something. Now, so the idea is that like this, you call init on RC with the value you want to store. Then you can call like ref any number of times to get references to it. But then you don't really do anything with the RC. Now we're deinitializing here because of actually we don't need to deinitialize. No, yeah, because we never call release. So this is just to don't get any. But really, you would never actually do that. You would actually just, and you can't do it either because this is like a private function. It's just available in this file. But if you do ref, we actually do like the proper way is to do like this. So you get a reference and then you release it when you're done. You get another reference, you release it when you're done. And then when both of them are released, this is also gonna clean up itself and the value inside. So that's the idea. All right, we got a whole bunch of errors that we need to take care of. Okay, so but the point is this is a ref. So basically we can kind of get a bunch of refs. Now one thing that I didn't think about is when you don't have access to RC, you probably want to be able to, you know, create a new ref from another ref, right? So let's say you have this, you want another ref that you need to, that you want to have. Now this is a ref, and you should get the same thing. And then basically we just return self. Well, we need to do the check here. If we have this, otherwise it's in an invalid ref. Now we just call ref there. So there we go. Now we should get another. Now a reference can now create another reference. Okay, cool. Okay, let's see if we can get through this here. So we get a reference, and let's see. So what do we want to do here? So here we just release it, right? So we're releasing. We have to do a try as well. So we're releasing the reference here. That's all we need. That's how you kind of deinitialize the reference there. We release it. Okay, and after it's released, this it can't be released again. Allocator. Let's just do this. There we go. Let's just do like this, and then replace you with allocator. There we go. Okay. Okay, let's go ahead and go through what we need to fix now. So here we're declaring something and it might be mutable. So basically, if it's mutable, we need to do something. If it's not mutable, we need to do something else. So basically what we want to do is we want to make, let's make a convenience function again. That is going to be like init. And we need an allocator. We need the name. We need a value. And is mutable. And this is going to return a binding. There's probably going to be some kind of, I guess maybe we could put RC error here. So instead of just doing this, we're going to do like init. And there we go. And I guess we'll do like a try. Okay. So what's going to happen here is basically like if is mutable, we need to create a reference counter type. So this will be mutable. Name is name. No. Mutable. Wait. No, this is gonna be. Yeah, that's the RC actually. So if it's mutable, we'll create the RC here. Actually, it's gonna be like RC is equal to RC. You know what? No, yeah. Do we want the ref, like to be easier to define these? We should maybe expand this then a little bit. Like the ref could create a reference counter of this type, let's say. So what if we do like init RC? Not sure if we need to call this like init RC or something, but this would return an RC. However, no, this would return a ref actually. Yeah. Also, this should be like RC error. Okay, that returns a ref. So basically, we skip the whole process of creating the RC itself and just create a ref directly. That's probably the more correct way to do it, actually, now that I think about it. Huh. Okay, well, anyway. Yeah, and this would do. So we will get rct dot init allocator value. So we would try this. Now we have the RC, and then we just return rc.ref. There we go. Because now when we have this type and we want to create a new type of this type, like we want to kind of create the first RC, like the first reference, we will do yeah, we will do like mutable, and then this would be init allocator, and here's the type here. So we have name, which is name, value, which is value, and that's it. There. Okay. If we don't have a mutable, we just return a constant. Name, so now you need an so basically here declare. Okay, now the thing is, what if we reference something like, what if we reference another thing that is mutable? Yeah, there's so many scenarios that you have to think about here. I mean, yeah, we have var, like, okay, let's do like var b equals a. Now, I wouldn't say that b is not a reference to a, so b would just copy a at this point. It's just copying the value, right? And then b is a separate kind of thing, you know. So we don't actually have kind of like, we don't really have like references right now. So we don't have references. So at this point, I think we could probably just get away with declare, where it kind of depends on where declare is called, in what purpose it's being called. Fresh declare. Reseed interpreter scope with context. So yeah, I'm just gonna assume that this is always gonna be, you know, creating it for the first time, like the first, like this is gonna be, this is not cloning a closure, as we say, yeah, this is gonna be declaring the original, let's say. So yeah, we need to pass in the allocator here, I think, or do we, is it self allocator? Okay, there we go. All right, so that is that. What is this? Oh, it's a different, okay, well, let's include RC error here, and that will fix that issue. This is a maybe a try as well, maybe, yeah, probably, no. Wait, expected point, oh no, okay, this is not a pointer now, this is just a ref, right? So that refs work, refs can be I guess copied, but they are not supposed to be copied like that, but they don't really need to be stored as a pointer, because they have everything they need inside there. So okay, what's going on here? So this one, actually, we just say binding dot the initialize allocator. There we go. We don't need to do anything weird there. And I guess we do like a RC error void there. Wait. You say const. Okay, well, let's do that then. Constant, and then we force it into a mutable. Expected type duper found const. Okay, yeah, same thing there. Error union is ignored. Right, let's do a try or see error. Okay. Actually, this is an defer. You can't try things in an defer, so we have to do that. Try that. I'll just do that. Defer. Okay. Wow. It really bubbled up here. Maybe we should just catch. Whatever. It should be fine. Error unit is ignored. Let's do a try. It's kind of annoying to have the initialize in the defer like this because, well, the initialize in defer makes sense, but having a error in, maybe we should just, maybe we shouldn't have an error. I don't know. It's just because we're trying to catch the cases where you do like a double release or something weird with the reference counter. So yeah, maybe actually I don't like this catch try the initialize. Actually, you know what, let's go back on this a little bit. Yeah, let's go back. We don't want this to be an RC error. What we want is we want to catch this here. Maybe we have this in all of those, but I want to catch this error and I want to say, you know, I just want to log some errors. So error releasing reference counter of type. We can catch the type here, and there's error, and then this would be like type name of. Actually, we could include this in the actual release thing, maybe. Double release. Let's have it here for now. The type, I mean, we know the type basically, but the type is no. Let's just do like of binding, and then we get the error there, and then we don't really care about anything else there. Error unit is ignored. There we go. Why is it ignored? Should be an error. You don't catch. There we go. You are that. Alright. Okay, so that one. Alright, there we go. Now, binding should be, let's do init. So let's add a convenience function here that will like get value. Now this could potentially be an RC error actually. So we'll get this error out and we'll return a, I mean, I guess this struct is kind of what we need. Like this is gonna be like the binding value, maybe. I don't know, binding value. Naming is so hard sometimes. Yeah. So this would be no, binding value, whatever. Binding value. Okay, because now we can say here, we can say binding value, and this would be self binding. Do we need to be a pointer now? And we just return switch self. Yeah, just self. If it's a constant, we will return value directly. If no. We just return C. If it's a mutable, we have to do like m.get, and yeah, that should be it. Except get shouldn't be a pointer here. There should be just T, I think. key, and then this is, if we want to get the pointer, we do this. There we go. Now if we want to do test, you can do this, and here we go. We have an issue here. 111. You can be an error, so I will just catch that, I guess. No. We don't expect this to be an error. Right now. It's just if you catch it, the error is gonna go away if there was an error, so I don't really want to do that. Maybe it's like whenever you get to the defer part, like if you get to a defer, it means you're at the end of the function. You cannot change the return type, or you cannot change the return value. So you can't have a try. So if you defer something that can be an error, then you know, that's a bad pattern here. Hey Rocket. Hello, hello, hello. All right. You do that. Have a good one. What would be a good way? Because there could be an error here, but how would we solve this now? I guess maybe release shouldn't be an error, to be honest. Like, we know that it's an invalid action, so we should really just ignore it. It's just that it could be a sign that something is going wrong. So like if you have, like, you maybe have more releases than you need, but I think maybe we don't actually have this error actually. So let's actually just remove this error. Like if there was a double release, whatever, you know. So now let's just remove that. There we go. And now the error is gonna happen if you do the other stuff here, but not on release. I mean, I guess maybe we could have a fatal, like, panic or something. Nah. Because the thing is, if you release something like multiple times, it's a sign that maybe you've used it more than you actually could have used it, and then there's potential of some kind of seg fault or something going on. All right, Penguin. Okay, well, let's just get rid of that. Sure, why not? Right, and now we don't need to try this, but we should now expect actually we should expect this to be null. This is the other way around. Come on, why don't you work? What? Did they stop working? Like swapping parameters? Yeah, we're expecting... Wait. Oh, I see. There we go. Now it should work. No? Maybe not. We expect that to be null, so fine. It's kind of annoying here because the RC is like totally blasted, so we can't even check on you know, what the value ended up being after this release, because it gets totally like destroyed and set to nothing. So basically all we have is a pointer, but the pointer is destroyed, so we don't even have the value. You know, we can't look at it because it's gonna be a seg fault there. So we just do this and hope that it will work. This doesn't really do anything. We're not really testing this now. I guess we could test if this is set to null. But it's kind of weird because we can't actually test if this is released. Like if we try to look at this value, we are gonna get a seg fault, and the whole testing thing will. Because I tried to look up, like, can you expect a seg fault to happen? But I didn't find anything. I mean, I didn't look very hard, but yeah, let's just hope it works. Okay, we'll do that. There we go. But here we can do like expect double release, but now that doesn't really do anything. So this, I'm just deleting this test here. What are you talking about? Oh, so you need, no, you don't need to try. You need to be a var. All the refs need to be a var. There we go. I did this worked before, so I'm not sure why I get so many errors now. Testing 74. What is this? Texting equals expected type. Expected equal ref get. Wait, where was that? RC 117. So this is pointer to that. Oh yeah, now this should be like get pointer. Yeah. There we go. Expected void found that. Try release. Error unit ignored. 37. No, let's remove the error. I mean, yeah. Let's just do that. There should really be a warning, though. It should be a warning, actually. Let's do that. Log warning. RC called release on non-allocated RC return. And then here we do the same thing here, like else called release on already released RC ref. There we go. There we go. Now it passes. Cool. I guess now we could add those tests, but whatever. All right. So where do we need to go now? You get, that gets us the thing. Cool. Release is not an error anymore. Yeah, there we go. And actually, no, that's fine. No field name value, right? So binding ref. Okay. Let's just do like get value. Try. And try get value. And then you will be binding value dot value. Why is it like this? This is a pointer. Okay. Let's add another one then they call like get pointer. Let's do like get and get pointer. But you need to be mutable now, and we switch on self, and these need to be that. And then here we actually need to do get pointer, except you don't need to be mutable. There we go. So here we will do get pointer, and now we have a pointer, which means we can now do this properly. And this one is like binding value. Well, okay. This would just be like binding is equal to mutable. No field. Wait a minute. No field name in. Yeah, okay, so same thing here. We get the binding value, except now we don't need the pointer. We can just get the thing and actually we could wait. Get pointer. Let's also do like get value. That will return the value directly, and this will return the value pointer. Right? Yeah, that makes more sense. U would be like value. U will be also value, except now we need to be referencing over there. And same thing here, we get the pointer and then the value and do that. There we go. Alright, and now we don't really need to do this. We can do binding get value pointer. There we go. Except we need to do a try. What? Expected optional binding ref? is happening? What is happening here? Okay, let's try and fix this issue here first. Let's do binding get name. Get name, but that's already a pointer basically. Yeah, let's just, we don't really need a pointer version of that. Well, so you could get the pointer to the slice, I guess, but whatever, let's just do this. Yeah. All right. Now what the? So now, okay, look at this. Expected type pointer to a value, found error or pointer to a value. Okay, so we get rid of the error by doing try, sort of. Now it's saying expected optional to binding ref, found this error here. Oh, I see. Okay, now it makes sense when I look up here. This could be an RC error. All right. And whoops. Wait, do I have to read? Do I have to dereference there? Yeah. And you are gonna need to do try. And then you need to be in RC error as well. Try. All right. What's happening here? Expected. Oh. Get pointer. Return dereference. There we go. Oops. Okay. Which file should we start? Well, okay, it's all evaluator. Okay. Imagine doing all this for nothing. Did Advent of Code today? No. It would be cool to do it in Zig, but I don't know. It takes too much time. It is fun, but it's like the thing is, I don't know, maybe they've changed a little bit, but basically I feel like those kind of problems, like where you're trying to do those kind of weird algorithms, and it's not really real life problems you're trying to solve, I feel like most of the time. And I don't know, I would rather solve actual problems. No, but it can be fun. Yeah. Today one isn't too hard to do. I have 50 something lines in Rust, including testing and file loading. Oh, this year's gonna be 12 days. It's just okay. Yeah, maybe. $20.25. Yeah, we'll see. Maybe I'll take a look at it later today. We'll see. Let's see. I'm deep in this now, so I have to. Scopes. Oh yeah. We changed this around. Okay, yeah. So what would this mean? It means basically we have scopes. Scopes is gonna be the closure. I'm pretty sure. Now we don't actually push a blocking frame, but we do push a frame. We do push a frame, but it's not blocking. It is going to have access to the outside world now. All right. What's happening here? Executor, push frame. Wait. What about this one? Wait, it's not actually used. What the hell? No, it's not used. Okay. I mean, I guess we could just set. We could set the scopes here to be this. And then we don't really need to do this. But let's do that. No. Actually, wait. No, because this is not a pointer. So either we change it into a pointer or we have to kind of do a move thing back and forth. Let's just make it into a pointer. Scopes. Yeah, we can do allocator, create scope stack, scopes equals that, try, and then the initialize does that, and then we also destroy scopes. There we go. Fresh. All right. Where were we? lookup is now a try. Right. Still need to figure out this. You are now a try. There we go. All right, we're down to this. Hey, Polaris. Thank you. Have a nice day yourself. How are you doing? All right. Where was that thing? We made the executor, yes. We grab the closure from the function reference, and then we set this scope to be that. Except, why does this work though? This shouldn't work. Or maybe it does work. But no, it's different. This populates this with the contents of this. It should really be this. It should be the same. Yeah. There we go. Yeah. All right. Tripod frame. Yeah, that's right. Wait, we're popping twice. Oh. Let's delete this. And also do this, so we have consistency. If this fails, we'll never pop it, but then it's like failing anyway. Alright. Run function is a function that reference. Alright. This is the only visible error left. To clone the scope. But then is also the issue with the mutable variables. You know, when you clone the scope, we need to create like references to the binding variables. There's probably going to be some issues now if we have a clean slate, like if you have like var a equals 5. When you import this library, var a is just going to disappear. I think. No, it's going to be in the top scope. Maybe. This scope never gets popped. Yeah, I don't know. Anyway, where did all the files go? Validator. All right, let's do this now. So, closure. Scope stack. Probably some kind of error. And what do we get? We should get a scope stack out. Okay. So first we will create a new scope stack. Scope stack. Then we will say scope. How do we do this? Do we just recursively go through everything and just add everything one by one? I mean, I guess. And if it's a constant, it could just be a I guess we just copy it. And if it's a mutable, we create a new ref. Yeah. So I guess we'll go through all the frames. So for each frame, now the self frame. So for each frame, we will push a frame using items, same options. Okay, we push the frame. We don't pop it, we just push. Yeah, we're just creating the things, and then in this frame we will, there's probably some optimization with shadowing you can do here, but we'll just push everything in here. So yeah, we have bindings. Yeah. So let's just loop through those. Oops. Now I don't think we need this to be a mutable or like a pointer here. So here this would just be like declare. No, it won't be declare actually. I guess it could be declare in case of this being a constant. Then we do a declare. Could we do declare directly on here? Oh. Let's do like declare name value false. Wait, why is that mutable? We move it. No, we don't. We don't move anything. Stop with that. Let's do that then. No, actually, okay. We need to then. We just need to copy it like this, and then we pass it like this. Okay, so that's the constants. We just basically copy them into this scope here. Now, I mean, technically we could also have like reference counters for the constants as well, and then yeah, I guess you could do that. Because then you wouldn't have to copy everything, you would just have one copy. Okay, well, whatever. Now we've done this. Or I've done this. M is something unknown. What? No, mutable. There we go. Okay. Now this one is different. So we probably need a different kind of declare function here. We need to like declare reference, and we could have like, this is the original binding. Now this could still be like mutable, I guess. No, it should just, yeah, it should just be all, it should be, it doesn't matter if it's mutable or not. Well, actually maybe it does. You know, let's just do this for now. So, because this is like a closure, actually this is like a closure ref. This is very specific to closures. Name binding, so we don't need the name because it's included in the binding. Alright, so we probably don't do this, but I guess we want this anyway to, for safety. The name, we only need to clone it if it's a constant. So let's do like switch on binding constant. If it's a constant, then we basically do whatever we do in here. Alright, now immutable is false. Okay. Value is going to be binding get value. Try. Name, just going to be binding get name. No, we don't. Yeah, okay. Yeah, maybe we do duplicate it actually. Actually, we have binding name over here, so binding get name. The value is kind of weird, because it could be something that is allocated. Like if the scope was destroyed, this constant gets destroyed as well. And now this one, if you have a function defined in another function, for example, all the constants will get like destroyed here. So we should actually copy the value. We should actually we should clone it actually. I think you can do clone like that, but then we also need the allocator. Yeah, and then this is a try in itself. I've never done that pattern before. All right, so yeah. We duplicate the name, we clone the value, and we do that. So I guess value owned is, we can do the same thing here. We try to get the value, we try to clone it. If something goes wrong, we will deinitialize the value. Oh, there we go. With allocator, and then value on. There we go. Oh, my clone is, yeah, it's just that. Okay. Now, if it's a mutable, we will get it here. And we will say, now this is a little bit easier actually, because we can just do try frame bindings append and then try, and then we do like a ref, and then the item is gonna be the binding. So we just do a reference to, wait, no, yeah, because this, no, M, it's gonna be M, yeah. Right? Isn't this wired up properly? Bindings. No, yeah, we need to use init. Or no. This isn't like an entirely new one. The other one initializes a new one. Yeah. We need to have a ref as well. We need to have a ref. But then if you're trying to do a ref on a constant, it's gonna be an error actually. I guess. That's fine. It's really, the purpose of this error is actually different, but whatever. Ref is gonna be like self binding. We don't actually need the allocator. We don't need this or this. Yeah, we just do this. And then we get another binding out. And we do a switch on self. If it's mutable, we do that. So if it's constant, we will return. Actually, we could just return like this. We'll return RC error invalid ref. If it's mutable, we're gonna do mutable, and then this one is gonna be reference to self get no, it's just ref. Yeah, it's just ref. Yeah, we just get another ref. There we go. And we don't use you, we don't use... No, we do use you. Yeah, because you need... Yeah, it's gonna be m ref. There we go. Alright. You're not used? No? I guess we already have the name, the value. We can just get like this. And then we can say value clone instead of this. A little bit easier there. And then we don't need to do that. There we go. Now what about this? This is weird. It should be like m.ref. Yeah, so I guess we didn't need ref on the other one. Whatever, now we have it. No, actually, no. This is gonna be binding.ref. Yeah, there we go. We're creating a new reference for that, and we don't really need this. There we go. Okay. Now, so that's declare. Now I do declare. Wait. Well, actually, now we could just use declare closure ref. Because if it's a constant, we do that, and the other way, and then there. So basically, yeah, let's do. We don't need to switch here. We just do scope declare closure ref on for this binding here, and can be an error, and there we go. I think, yeah, simple enough. I think this reference counter works really well with these scopes here for this particular use case. Okay, now let's clean this up here. You need to return, so we return the scope. You I guess need to be a var. There we go. All compiler errors are fixed. That means everything should work. Okay, so what have we done? We've created closures for functions, and hopefully the ability for them to now they can reference things from outside of the scope and or outside of its own, like, yeah, its own scope, and then also modify variables. So basically the kind of code that we have right here, this should now print whatever we're saying here. I'm gonna remove this. Well, okay. The thing is, we don't actually have reassignment yet, so we can't really test this here. However, what we could do is, let's say we have var a equals to 5, and I'm just gonna test run this so we don't get any weird stuff happening. Okay, we do get weird stuff happening. Scope 218. No address available. Bindings, items, finding frame. Declare. So we're trying to declare a thing, and it's mutable, and we're trying to find it in frame. General protection hold. Is it because of I was thinking maybe the move from scope stacks to be like pointers instead of not pointers. Current frame. Do we forget to push a frame, or what's happening here? Current frame. No, then we would get this. Read from context. Execute. Where is it like initialized? Here. Init with runner. So where's the scopes? They are here. We're pushing a frame. Okay. That should be fine. Because we're creating a new pointer there. What else is happening here? Why is it a constant? That doesn't make sense. Like, sure, this is a const enter document, but the pointer is not constant. What? I mean, this is probably not the issue, but yeah. Okay, I just what the hell? Why is this like a constant? That doesn't make sense. Okay, anyway, what is happening here? We're just taking this thing and this context. We're going through bindings. Like, this context is something else. And declare. I don't think this actually does anything. We're doing like a push frame, but Yeah, it doesn't really do anything. And then previous, wait, what's happening here? Previous is scopes. We deinitialize it. What the hell? Right, we're making a new one. We're deinitializing it if something goes wrong. We push a new frame. We put all the things in there. The previous is set to the new one, and then the previous is destroyed. Okay, I guess that's fine. No, it's not. Yes, it is. No, it's not, because now this is a pointer. There we go. Alright, so we got some memory leaks. That's a way better error to get. Scope 157.557. You are leaked. Okay, okay. Declare. I do. Hello Penguin, welcome back. Hopefully this whole ordeal will soon be over, and maybe it will work. We'll see. This creates a new thing there. Okay. Yeah, that does make sense. Why would it be leaked though? Bind pattern. Because at the end we should be deinitializing it. Yeah, we're deinitializing the binding. Here we're deallocating the name. So and the frame should be called here. Wait, what's this? Oh, that's binding, right? Deinitialize here. We go through all the frames and we run deinitialize on them, and then we also deinitialize that. We also deinitialize when we pop. Oh wait, this is an issue actually. No, it's not. It's not, because we're using reference counters. The magic of reference counters. Okay. But why is this leaked? It's stored in the binding here. Wait, do we copy it here as well? Yeah, no, we just store it as it is. Except it is immutable. Yes, it is immutable. So when we go in here, we initialize the thing. But that just does that. Oh, wait. Yeah, we release. Release. deinitialize. If t has a function deinitialize, we call it, but that just calls release. Wouldn't this be like a infinite loop here or something? That calls release. I guess maybe the mutable needs to have like a boolean or something that is like is releasing or something, and then when deinitialize gets called again, it will check if is releasing. We will instead do like proper deinitialize. No, actually, no, we're doing, no, actually, yeah, okay, this is the issue here. We never, yeah, we need a deinitialize on this one, that's it. We need a deinitialize here. So this would be binding value, and then we need an allocator, and then this would be void, and then we just do free on main and initialize allocate. There we go. This is the function that gets called. Yeah, I guess you need to be mutable, fine. No. Yeah, it works. Okay. So, okay, now let's try and print it. 5, great. However, we don't have reassignments, so this won't work. However, we could check. We could make a function. Our default function is called hello now, which says hello A. So let's do the integer overflow. What? Oh, we're creating a closure. Okay. There's something going on here. We're creating a closure. Integer overflow. This tells me that maybe like... no, an integer overflow. That's weird. It doesn't tell me anything. Scoop. Well, okay, what I was gonna say is like it tells me that maybe there's something wrong with that we're using like an undefined value or something. This is like append, add 1. Okay. Push frame. And if it's set to like OXA, then we could have got maybe a overflow Perhaps. Where is it happening? Some kind of weird like length times, yeah. So if the length is set to OXAAAAA, then that would be a huge overflow there. So this would be the list of frames there. Oh, I see. Do you see the issue? I challenge to anyone who's viewing right now to see the issue, because I just saw it here. It's a pretty simple mistake. Alright, so the issue is that we create this one here, but we never populate it. So basically, when you use the allocator to create something, you get a pointer to the thing, but then the contents of this pointer is like undefined, which means it's like OXAAAAAA. So we have to initialize this with an allocator. Why do we need an allocator? Because frames... Wait, is frames actually a managed array list? What the hell? No. Also, we made our own. This doesn't make sense. This is AI here. Let's... no. It's gonna be this. We're gonna set it to empty. I mean, we can, it's so weird. It's like managed array list, but we also have allocator on self. So we're storing allocator both in here and in here. That does not make any sense. Bindings, yeah, same thing here. Array list, empty. There we go. And we don't need allocator here now. And we don't even need to set you to anything. Here we go. Here we do need allocator. But you need allocator now. There we go. You don't even need to be set. You append what? Lexical. Where did that come from? Alright, there we go. Okay, let's see if that solved the issue. So now we're initializing this here instead. Cool. Let's do build first, so we see that it actually completed the compilation. Alright, so now we have leaked memory again. There's a lot of leaked memory logs. Still, scopes declare. Oh, wait. The function ref, right. Function ref. Do we actually have proper, like, the initialize here? No, we don't. Function ref. So we don't do anything with the function declaration. We don't do anything with the scope. However, the closure we do need to clean up here. So self-closure, deinitialize. Oh, we don't even need the allocator. Okay. Fine. There we go. Now, also here, deinitialize function. There we go. Now that's properly deinitialized there. Cloning, like the closure now. I guess it makes sense. Yeah, we might need to implement that for the closures now. But it's gonna be super easy because you just create another closure, I think. Still more memory disks. Oh, they reduced by quite a lot there. All right, so another closure call, execute function declaration closure, create scope stack. Okay, so the actual okay, so we took care of the contents of the pointer, but not the pointer itself. So we actually do need the allocator here. And then allocator destroy self-loop closure. There we go. All right, let's go back. And now we call hello. Okay, I saw that it worked, but then we got issues. Okay, let's fix this last thing here, and then because we don't have reassignments yet. I don't have. Okay, let's see if we have time to do reassignments instead, because then we can test this out fully here. All right, so where is this happening here? Duplicate, name own, still this thing. Scopes declare, bind pattern, execute binding. Okay. Execute statement, function declaration, binding, and then here we have the RC got leaked as well. So it's something with the scopes, and then this one got leaked. Script. Okay, so here we can run script 84 init with runner. Yeah. So basically, yeah. So when the document gets deinitialized, this one gets deinitialized as well, which in turn should deinitialize the scope. Oh, we never destroy the. Yeah, we do. We do destroy the scopes. Okay. So why is here we create a scope, we populate it. Actually, we should also destroy it if something goes wrong. Alright, we push the frame. We then return with this. So, yeah, I mean, how come that one is not destroyed? I wonder. No, we never deinitialize here. No, but yeah, but we deinitialize the document, right? Yeah, we deinitialize the document store. We should deinitialize the thing here. Yeah. So what the hell? It says that this one is leaked. Script executor 72. Run from run script 84. And then we have this one. Wire command bridge. You basically don't do anything. Reset from context does mess with the scopes. Actually, it does mess with the scopes, so we do get, yeah, this was what we looked at before and solve the thing. So we get a fresh scope here. We deinitialize it if something goes wrong. We push a frame. We go through and declare, but we never actually do this because there's nothing in the bindings here. And then we grab the previous scope, which is now should be constant value. We set the contents of the current scope to fresh, and we also deinitialize. Oh, I see. We never destroy the pointer, the old pointer. Okay, so we don't need to create a new point. Well, we don't. Okay, so we don't create a new pointer, but we do. Wait, what? No, yeah, because we're just reusing the same pointer, so we're never like reassigning the pointer itself. Yeah, so we're reusing the pointer. And you just do this. And then we run a bunch of executes. I mean, there could be something happening in here which does some weird stuff. This scopes is from there. Yeah, it's just self scopes. Okay. My brain is getting fried. Let's see. Right, let's get rid of these things. Alright, this creates a new closure. We create a new scope, we initialize it, we're going through all the frames, pushing a frame, going through all that, declaring this. This doesn't really do anything with the original, we just use the data to copy the scope there. Yes. And then we store it here. And we bind a pattern on this scope there. Hang on. Oh, file not found. Okay, well it shouldn't crash like this, but whatever. Let's do clear and then this. Okay, actually, I also want to do this. What if we do this and then I only... Actually, what if we do this? That should be fine, yeah? Then I only do a function. That's fine. Function with a statement. That's fine. Now, calling the function. Now we get another memory. So calling the function gives us a memory leak, or 3 or 4. Okay. So it might be okay. So it might be the execution part. Then it might be like you know, run function as pipeline. This might be the issue here, because we are. Where's the thing? Run stage function. Here we go. So basically here we are creating a new, no wait, what? Here we go, run function. Here we're creating a new executor. No, we're not. We're grabbing the executor from the document here. In the same manner as the other one. And then no, we just return this error. Going on. Alright, I don't know. It's just something with the LSP saying that this is a pointer to a const script executor. It should be a pointer to an executor. So I'll just change that. This won't solve the issue. Yeah, still the same thing. Yo, baby Yoda, what's up? I don't know which is better, carbon or rust. I never tried carbon. I don't think I've actually seen carbon, to be honest. What kind of language is it? What is it? Because I don't know. In my mind, I'm kind of thinking about like some kind of C++ replacement or something. But I might be totally wrong. Safe C++. Okay. Isn't C++ safe? Safe enough for you? With all the pointer types or pointer kinds. I don't know. What was I doing? Okay, so this didn't solve anything. We get scopes. The whole thing is here, like, we don't actually deinitialize this executor. However, the scopes. Here we reassign this. Okay, this explains things. We should like. Yeah, this is entirely new. No, it's not a new executor. We're reusing the executor. We should like refit the executor once we're done here. We should refit it with the original scope. This is a stupid thing. This is a stupid pattern here. Because if something goes wrong in between here, we still have like cleanups. We still need to like clean up both scopes somehow. So let's say something goes wrong at this point. We have to clean up. Yeah, the first happened in reverse order. But if it's an error, what will happen then? The first or the first? Yes, it's the same maybe. C++ is not safe for mental health, not safe with pointer. Speaking of that, I implemented a reference counter here in Zig now that I can use for these scopes. And it's interesting. If it works, it's kind of cool. Or reference counter, I should say. Reference counter pointer thing. So basically, automatic garbage collection in Zig. Hey. I'm just trying to think which need to clean up now. Is it this? So this should happen first, which means when this gets cleaned up, this should get cleaned up. So we need to clean up the closure, but that's gonna get cleaned up as well though. Maybe this is enough. Okay. Yeah, so now we reset that. Oh, that was it. Okay, cool. Well, okay. So we did, so, okay. Awesome. So this works now without issues. Now, will this work though? Yeah, it works. Awesome. So we have closures now. This refers to this. Now you might think that, oh, now you can do this and then try again and even do, you know, here. Name. Before hello. After hello. Hello before. Hello after. However, there is a parsing error here. Why I'm not getting the parsing error? Oh yeah, but it's basically here like A. Now this is like parsed as kind of like a pipeline stage. So equals doesn't make sense. We need to be able to support reassignment here. I was searching for the easiest way to convert bool to int in Go and got map bool int because you can't just normal cast. What is map? There's a good way of doing it, but on the side check it was like number 7. I don't know what's wrong with this. Okay. A bool to an int. So like true is 1 and false is 0. So what? How does map work in Go? Like, is it just kind of like, oh, it's a hash map? What the hell? So you're creating a map of bools, or I don't understand. Yeah, a hash table. But what do you get with map bool? Like, is it the key that's the bool, or is the key always a string, and the bool is like also? Where does the int come in? How do you get the int? I don't get that. You can do int. No. That's not good. Key can be any binary data. Oh, okay. Generics, right. Right. I'm gonna see if we can make this this expression happen here. So basically, we want to check if we have an identifier equals and then something else. So then it will be an assignment expression or reassignment expression. So we need to go to the dear old parser. Parse. I'm gonna go to parse pipeline. Parse pipeline, because that's where we kind of do these things. So here we have like an identifier expression, and if we only have one identifier, it's gonna be a pipeline. Here we're checking like next tokens, and yeah. Okay, I guess I'll keep this, whatever. So if it's a dot, we do some stuff. If the next token is an equal thing, where is the thing? Equal. Equal. Wait, don't we have equal? What the hell? What is this? I guess fastest way to do it in the language. Got to go. People tell to use an if. Why would I use an if? I want to be branchless programming. Well, doesn't. I mean, if they had compiler optimization, then that should take care of it. I would rather have like readable code, and then the compiler will like optimize it, than to have a bunch of strange spells. Okay. I mean, I don't know. It's kind of interesting because in C or whatever, the bool is just 1 or 0, and that just fits so much better if you want to do those kinds of optimization. It's already an int, kind of like. So you don't have to do that weird thing. Okay, what is happening here? Equals. When are you being called? There. Assign. Oh, it's called assign. Fine. Okay, if we have an assign, we want to we want to get an expression at the other side. So next token. So this one, the first token is the identifier, I think. Yeah. So we'll consume 2 tokens. And then we try to parse an expression. This is going to be kind of the value. Parse expression. And then we return an assignment, maybe. I don't know if we have this. I mean, okay, no, it's actually a statement. Where are you? There you are. Binding, function, error, expression. So this would be an assignment. Yeah, we need a new thing. So we would have the expression is you know, expression. And then we also need the identifier. Expression, yeah. We could have different kinds of assignments, maybe. I don't know. But we have the assignment now. Alright, so Let's go back. Where? Oh, we are here. Okay. Assignment. So now we have assignment, or do we? Yeah, we should have. No, it's not an expression, right? God damn it. It's not an expression. No. Okay, wait. It is an expression. Sorry, it is an expression. It is an expression. I mean, it could be a statement as well, but it's actually an expression, because the result is gonna be whatever value you get assigned. So, yeah. Excuse me here. It is an expression. There we go. Let's add this down here. And of course, let's move you somewhere. I don't know, here maybe? No? Here? Alright. Let's go back to the parser. Alright, now we have this. And the expression is going to be that. And the identifier is going to be the identifier token. Actually, do we have like from token? No, we don't. We should really have a from token. What? Okay, you know what? I'm just gonna use the Lexeme. What is that? Oh, cost. Span, token span. There we go. I just wanted to check if we keep, we don't, you know, allocate this or anything. Okay, so now we have the assignment expression there. Cool. And we just need to, okay, we need span as well. So let's start at the identifier and we end at the expression. There we go. Now we just need to support this expression. And what the hell is this? Populate stack expression. Oh, this is the walker, right? Oh yeah, so cursor and expression, assignment of expression. There we go. Alright, that was easy enough. Now we will go to the evaluator. And we should have an assignment now. Evaluate assignment. It's also so much easier when you actually have like more and more things in place, like more and more of the basic like foundation. It just flows a little better, of course, and then you can just expand on things. Remember, now we have an assignment. And yeah. So assignment. Now, here we need to check like if, so basically we get the binding, look up assignment, identifier, name. So if we didn't find it, then this is gonna be like some kind of error, I guess. Because we don't allow, you have to declare a variable. You can't just create a variable from nothing. And that's not declared. So this is gonna be something here. What the hell is this? Antivirus? No, this is not. Wait. No, that's from Zig standard library. Invalid ref, bad path name, access denied, broken. No. It's gotta be like binding not found or something. Invalid name, immutable binding, member not found, name too long. Don't we have like a no. What could we use? Unknown binding, unknown identifier, unsupported binding. No, I guess unknown identifier maybe. Not sure where that is. It is here. It's used there. And identifier. Evaluate identifier. No, this is when you use the value. That's right. But yeah. Wait, no, this is assignment. Okay, so we have the binding. Now, if we need to switch on the binding and say if it's mutable, we can do things with it. If it's not mutable, we need to return some error here. So this would be like immutable binding. Very descriptive here. Okay. So now we have like a value, we have mutable. Actually, this is a binding ref. Wait, no, yeah. This doesn't make sense. Binding value. Now, okay, so then we have like is mutable actually. Binding is mutable. So this is a ref. It's actually a ref. If it's mutable, we do things. Otherwise, we do this. Return. Alright, if it's mutable, we can change the value. Yeah. I guess we would want to look at the type. Like if we could do some kind of type check here. And this is the point in time where you could decide like, okay, now it's gotta be dynamic types. because we could potentially just change the type here, but I'm not gonna go that route. It's gonna be, you know, if the type is different, there's gonna be a type error here. Let's do reassign value, and then like we have this, we have the expression. We need to evaluate the expression. New value is gonna be assignment expression, and we need to evaluate this expression. Scopes and expression. There we go. Probably some error. So we get the new value out, and then you will be like reassign with new value. We do a try there. Okay. So reassign with a new value. Can be, you know, value error. Actually, let's just call this error. Error type mismatch. All right. So basically, we just want to check if this if the tag of this I wonder if this works on, no, you have to dereference, I'm pretty sure, is equal to the tag of this. If they are not equal, then we need to return type mismatch. But if they are equal, I might have to go here soon. If they are equal, we will just populate with this new value. However, we do need to like deinitialize as well. So let's need an allocator as well. There we go. And I guess the new value is then moved as well. All right. I just want to tie this together here. What is this error here? Oops. Field access. But I'm doing a try. Oh. Or else return. There we go. Member function. Okay. So you need an allocator. So there we go. Yeah. And then we don't initialize this because this is put, like moved into here. Yeah. It is muted. Okay, there we go. Whoa. Okay, now it's complaining because we don't return. So yeah, an evaluate assignment should evaluate into the value that it was assigned to. So this should be new value, except the new value was moved, so we actually need to take this one. There we go. All right, cool. And yeah, is that it? No, we got something here. Expected union or enum unit type found. Oh. Active tag on that. Oh, there we go. Cool. Now you need to be dereferenced there. You are ignored. Oh, I see. So you can do like dot move. Okay, so you can do this. Alright. Great. No more compiler errors. It works. Wow. Okay, okay. So it works. Cool. All right. One small step, you know, at a time. Baby steps. Main before hello. This is called first, or this is run first, and A is 5. Then we run hello, which says hello before A. Hello before is 5. We set A to 2. Now this is set to 2, and then afterwards is set to 2 there. So it's basically, and everything is a reference basically right now. Like you would maybe want to have like you could argue that you want this to be a pointer instead, or I mean like a reference now instead, like if the type is kind of like a, I guess, a pointer int, then this makes more sense, you know, if you want to do something like this. But right now it's just, yeah, this is how it works. I'm not exactly sure how we're gonna deal with those kind of semantics, but at least it works now. So awesome, we got like the foundation of the closures and everything there for references and stuff. What if we now try to do like b equals 3? Okay, just testing one step at a time. And here we try to reassign b to 6. Then we get immutable binding error. But also it keeps going. Yeah. Yeah, okay, so that's one thing. And then we try to, let's say if we try to set this to a string, and that should also be an error. No? Oh, it bailed out after this. Okay, now let's do this. Okay, now we got some big memory and stuff. But we did get type mismatch. So, yeah, that's pretty cool. All right, I have to leave here now, but yeah, pretty cool. We got some stuff done. So we got reassignments. We don't have arithmetic yet. Did we do anything here? No, not that, not that. Not this, not this. Okay, we just did. Oh, we did closures. Yeah, that's right. Just a little thing called closures. Okay, cool. So that's gonna be it for this time. I'll yeah, I'll see when I can get back here. Maybe tomorrow. We'll see. But yeah, thanks for watching, and I'll see you later. Bye bye.